It'll give us a running start. Okay, so equations in quadratic form. So these aren't necessarily that are quadratic equations. These are equations that when we have some expression in x that we can represent as u, if we can put that in as a quadratic equation, then we have what's called a quadratic form equation. So when we have something like this, where we have x to the fourth minus 5x squared plus 4, that's definitely not a quadratic equation, right? That's x to the fourth, not x squared. But if we look at this as maybe define a u that equals x squared. So we're going to choose this because if we take u squared, we get x to the fourth, and then by a substitution, we can make u squared minus 5u plus 4 equals 0. So here we have now a quadratic equation that we know how to solve. And so we solve this, this particular one by factoring. But instead of just declaring that u equals 4 or u equals 1, what we want to do is set up the equations like this, and then, since we're not really interested in u is something you defined, okay, you want to find x, and so you substitute back in what x is. Now x squared equals u, so you want to put in x squared minus 4, and notice that that factors, and we get a solution out of that, and the other one factors, and we get a solution there. So we have actually 4 solutions, x equals 2 or negative 2, x equals 1 or negative 1. Now, when we have polynomials with the degree of the polynomial suggests how many possible solutions we have. Doesn't mean you're guaranteed to have 4. You can have 0, 1, 2, 3, or 4 solutions with this, but you can have up to 4. So here we actually do have a case where we do have 4 solutions. Okay, so something else that may not look like it's in quadratic form, but it is. The key to these things is spotting the fact that you have some type of variable expression and the square of that variable expression in the same equation. So they may not be in this order, but you realign them and then you make a substitution where you have u equals the square root of x, so u squared equals x. And now when we put in the u squared for the x and the u for the square root of x, we have this quadratic equation. And so we'll factor it, and we'll try and solve this. And so this first one works out where we have the square root of x is 6 and x equals 36. The second one, we're going to run into trouble because if we look at this equation here and we subtract 1 from both sides, we'll have the square root of x equals negative 1. And there's no value that does that, no real number that does that. So we say there's no solution out of here. We check the one that we did find and find that that indeed does work, so we have exactly one solution. Okay, so we can have other things like fractional exponents. Here the recognition is that by using the power-to-power rule, you can square x to the 1/3 and get x to the 2/3. So there's the basis of our substitution, where we can say x to the 1/3 is u, x to the 2/3 is u squared, and so then we have 2u squared plus 5u minus 3 equals 0. So quadratic equation, this one factors as well, and then we solve each side separately because one of them has to be 0 for it to be true. And in this case, I solve for u, but then I make the substitution back, x to the 1/3 equals 1/2, or x equals 1/8. On the other side, we have u equals negative 3, and so the cube root of x equals negative 3, so if we cube both sides, we find that x equals negative 27. So we get 2 answers, and I did check them. I don't have it explicitly checked here, but both of those work. Okay, so here's one for you to try. Did you try this last Friday, or this was new, right? Okay, so why don't you try this and see what you get. Everybody see that as your substitution? So it's identifying something that you can have as u and u squared. Okay, what's the next step? Anybody?
Minus 5x plus 6 equals 0.
Yeah. Okay, make sure you're not missing. You're not mixing u's and x's. You want to get rid of all your u's, and then of course we factor it. We solve the first one, u minus 2 equals 0, so we can substitute back in the x squared there, and we get x squared equals 2. So x equals plus or minus the square root of 2 for the first one. Second one works similarly, except we have a 3 instead of a 2. And so we get x equals plus or minus the square root of 3, so we actually have 4 solutions again, all radicals. Now you don't have to write it exactly this way. You can still use the x, the plus or minus, so long as they're all indicated there. Okay. So how about trying another here? So these do follow the pattern of examples that I've shown you earlier. Okay, so just for completeness, I got it on the charts here, done exactly the same way. Okay, so here's another one with exponents now. This one is to a fractional exponent. Okay. And so then what equation did you end up with?
U squared plus 5u plus 6.
Okay. Did you bring that all the way down to an answer?
Yeah. And then factors u plus 3 and u plus 2. And then you can go x to the 150 with negative 3. And you get x equals negative 15.
X equals
Negative 3 to the 5th power.
through the 5th power, right? And so that's going to be 243.
Yeah.
Negative 243. Okay. And then you got the other side?
Yeah.
Similar treatment?
Yeah, same.
Okay.